So this is the section where I can talk about the stuff I've been working on. Let's take the idea of community, because this is my 28th year, 28 and a half years that I've been developing this stuff, all through the Ape SDK, as it's now called. And one of the things that interested me is there have been times where I've had a number of open source contributors, either formally through Apple and Intel, or informally through just people who are interested in partaking in some aspect of this simulation work. And it's always been really great to have people who are actively involved in the stuff that I'm doing. I've had a fellow called Bob Mottram who's worked on the simulation for maybe 5 years in a row, and then another 3-year stint. And just having that interaction with someone is really, you have this kind of gestalt thing where the sum of its parts are gradually greater in the interaction. So I'm not sure how it actually came about, like a lot of these ideas, but I was contacted by Dr. Liz Swan, and she asked me if I was interested in writing a follow-up chapter to my Origin of Mind chapter that I wrote in 2013. My Origin of Mind chapter is very interesting because it's probably the last academic paper. In fact, it is the last academic paper that I got out before I don't know how one would call it. Before professionally, it was more difficult for me to put out academic chapters, let's just say. So it represented a period of time just before contemporary machine learning had become relevant. So it was actually looking at a number of different simulation methods that achieved some form of AI at the end of it, fundamentally. And I love that chapter. It's a chapter that I did originally as a talk, and brought a lot of people together and got a lot of really great questions at the end of it. So being approached by Liz Swan for another chapter in the follow-up, which I think is called Where is the Mind Now, or something like that. The original one was called Origins of Mind. Made me think that I needed to find a way of basically simulating what the contributors to my open source had been up until this point. And there have been many different contributors at many different levels, for want of a better term. Levels is not a particularly good term to use with regards to programming specifically, but they've had different agendas, different interests, and ultimately come to solve the different set of problems, each individually unique and amazing. So I started looking at generative AI as a means of creating these kind of contributions. And this is a very political thing, because obviously the notion of replacing software engineering with generative AI is still, being regularly discussed. And it is something where I've talked to a lot of my contemporaries that I work with and told them a little bit about what I'm trying to do. Many of them are very complimentary about the approach, but I think it kind of spells an interesting period of time when potentially, I'm not sure the number of open source projects. I think it's in the millions. I think it's in the order of 4 million, or maybe that's the number of podcasts there are. Anyway, there's some huge number of open source projects that exist. And the ability of having generative AI and maintaining these projects and actually adapting them and moving them forward as processes change, as operating systems change, as all these things change, strikes me as a very interesting result, basically, of generative AI. Now, somewhat politically, DeepSeek has become the new benchmark with regards to generative AI. It's also remarkably good at programming in C, which is the language that I write most of all my simulation in. So previously using the ChatGPT-based programming, 65% of it would compile. It was really a very rough shot associated with actually getting output. About 95 to 98% of DeepSeek C generated compiles. And it also, you can phrase very difficult, if you find bugs in software, you can describe the bugs to it and it will actually be able to trace the points that are causing the bugs quite successfully. So it's a very interesting project now, because I'm taking, so folks will be familiar from this channel associated with associated with London 1940, displayed at Copenhagen, where I was looking to get someone involved with this simulation work, because it was just getting too great. As Matthew has noted, I have young daughters. My time is relatively limited. My sleep capacity is relatively limited too. So these kind of things play a factor in it, but I'd love to get London 1940 back up and running. And there were half a dozen bugs, basically simple software bugs, relating primarily to the Apple version of the simulation, which I've been able to squash, irrespective of this generative AI discussion, although one of them was solved through generative AI. And that has reawakened me associated with this project. London 1940, for me, was a very exciting, very vibrant project. I think the movement between it being, well, it's a fascinating period of time because it's a period of time where London was being bombed. If you remove the war from it, the war elements from it, then you get a far larger group of people that are interested in at least participating in the simulation. But there are other interesting examples, like, for example, the telephone directory is owned by, I think, Ancestry.com and British Telecom, an interesting, two entities to own. So you can't actually get there was a lawyer at this particular location, there was a doctor here, there was people making plates here, there was a, horseshoe maker at this particular location. You have to add that to the simulation after the fact. So the problems I was having with London 1940 related primarily to the amazing and eclectic number of building shapes that existed in London in 1940, and actually getting that back into the simulation and then generating rooms within the buildings wasn't problematic to me because I'd already written an internal room, based on tree structures actually, to find what rooms would optimize through various shaped buildings. But actually getting the building shapes as I needed them was the critical part. Now, through talking to the generative AI, I have a few ideas of how to solve this. There are a wide variety of solutions that already exist in Python, which is interesting as a C developer. So I tried to pull some of those out of Python into C, but I think there are simpler ways of actually framing the problem. And what becomes interesting now is my relationship to the project is very different than it was being a solo developer. I now literally have conversations with generative AI to create the components that I need. And what's interesting is this notion of shared source code where the paradigms remain the same, because the generative AI will love to create different paradigms at different places, and source code just comes together like spaghetti. But what you really want is you want to be able to comb the spaghetti into straight lines, ideally. And getting that kind of interaction is still something that I'm having issues with. I think it's just associated with how I actually frame it. But it is an interesting project. It's an interesting project from a documentation perspective as well. Now, how does all this relate to artificial life? This might be the big question. Once you have a simulation, I'm simulating Canterbury currently because it's the right size compared to London. Canterbury is about literally 100th the size of London. It's actually it's at the bottom of what the area of London that I'm going to be simulating. So simulating Canterbury will still be useful in the broader simulation, but it gives a very well-defined smaller area of which the buildings and the structures, obviously there's a famous cathedral in Canterbury, but there's a whole series of terrace houses around the cathedral. So simulating the internal structures of those is not so difficult. It's just actually getting the structures there. So that has been the past, I guess, 2 or 3 months that I've been working on this, with the view that once you have the structures there, you then have agent models that go through. They have professions, they have incomes, they have movement reasons, they have a wide variety of things that kind of take the simulation in various directions. And that is taking from my Ape SDK what has historically been called Noble Ape, what is now called Simulated Ape, taking those agent models and actually putting them in this case, Canterbury in 1940. I'm trying to generate as much reusable componentry. I have a friend who was big in video games and did a Las Vegas video game within the past decade. And he has a map of Las Vegas to a particular resolution. I think Las Vegas 1940 would be an interesting enough simulation too. So I don't think my obsession with regards to London and that area is really anything more than, at the time, we're talking about COVID here, through COVID, London had gotten, there was a strange series of both fictional books, but also really interesting, dissections of what happened to London in the late 30s to the late 40s, basically. Obviously, there's a war there, but in terms of architecture, in terms of a kind of cultural renaissance, a lot of that was being written about through COVID. And I think I found a number of like-minded folk, returning to my discussion with Matthew about this, that sometimes finding a community is a useful thing as well, just in terms of a motivator. So kind of juxtaposition of what used to be done by people who I'd communicate with, very similar in some regard to communicating with generative AI, but not quite as just a different kind of communication. And seeing what they created through this, seeing now what the generative AI is creating through this, it's a very interesting and somewhat political project, which I'm really looking forward to actually finalizing into a chapter. I know I passed this one on to you, Dr. Adams, because she was looking for, emergent people in the field that might be able to write additional fascinating chapters. So your name was certainly pretty quickly in front of my head to get back to Liz. But anyway, that's the project as it is currently. Do either of you have any questions?
With generative AI, what's been your experience been? Do you use GPT at all?
No, that's what I'm saying. Is historically I used GPT to lead in, and I thought it was going to be almost be a joke. I mean, I thought the whole notion of actually getting this to replace open source developers. Now, I have seen there are corners of GPT which apparently have been expanded specifically around programming and specifically around self-referencing programming and feedback associated with bugs and these kind of things. I wasn't ever able to get that out of ChatGPT. My view is ChatGPT is, as it's commercially available, is not particularly ideal to programming. I know there are spin-offs that claim to be programming for $12 a month and this kind of stuff. Part of open source is it's free as in free. I really didn't want to pay for anything, which is why DeepSeek coming along has just been fascinating. I've tried to run the local version. I think it's called Deep Code or CodeSeek or Code DeepSeek or whatever. Anyway, there's a code version as well, which has a smaller model. I've tried downloading it, tried using it. No, unfortunately, the web version is the way that I've been rolling recently, and it seems to actually provide what I need. The ability to describe bugs to it, specifically bugs that it has introduced, and it finalized that, usually a 2 or 3 iteration process. The difficulty with this is that whereas historically I would be programming and communicating and emailing, it's almost like it's like an introductory programmer. It's like working with someone who has a lot of great ideas but has never actually implemented them. So it's a very different thing, and it's very time consuming in one regard, but I think it's also quite fruitful in another regard, because it forces ideas. You can become very set in your ways when you develop open source for long periods of time. And it's forced me out of that to think, oh, it's actually changed this aspect of it, which makes this more interesting. These things will be able to fit together slightly better. I mean, you have to be on your A game still with the interaction. But yes, I have used ChatGPT historically, and it was going to be the end of this chapter if I had to actually do it. DeepSeek coming along has just been a complete saving grace to the whole thing and moved it into a different sphere.
I've played around a little bit with DeepSeek and the local models. I haven't had the opportunity to go too deep into it because this past month has been chaotic for me. But I'm looking forward to just kind of playing around with and seeing it, because if I could have a local model that I could run with my files and be able to actually, hold what I'm working on in context, that'd be game changing for me too.
Yeah, personally, I've actually been using generative AI models for all sorts of different things. I have tried it for programming, but to be honest, I kind of am still just in the groove of just like, I know how to do this, I'll just do it really quick, right? I think that I'm going to explore how new models can maybe make some of that faster. But outside of even programming, I've been using it for a lot, actually, like for studying concepts. So in my free time, I am always thinking like, oh, I really want to know, like, I took like thermodynamic courses in school, which was great, but I feel like I've forgotten all of it, right? And since this is known knowledge and there's a lot of data out there to train these models, I thought, well, you know what if I just have like do one of those like conversation sort of like chats with it. So I've been using the GPT, like the voice functionality, and you can like personalize your chatbot. And I've been having a blast. Like anytime I have about 30 minutes to just spare, I like to pull it up and it remembers the conversations before, and I will just go through things like see what I did a couple nights ago. I went through the oh God, what was that proof? The incompleteness. What was the incompleteness? Yeah, Turing's incompleteness theorem. And I was really interested in learning like the mathematic structure for the proof, which I thought was really fun. So like I've been using it for things like that, which I really enjoy. But it's also really great for things like if you're writing some admin paperwork and you're like, rewrite this as a list, a bulleted list. Boop. Oh, okay, like turn this into a table. Boop. I love that. It can just do all that kind of stuff. So, I never really got the sense of like, oh, this is a tool that can write like my next novel for me. Like, no. Like it can do all sorts of things that are really unexpected. And I feel like I'm doing all of these experiments to sort of discover all the different ways that I can use it. But I really just see it as a tool and not something that can replace the general direction and the big projects that I'm working on. So yeah, I'm really looking forward to how these tools can speed up my own programming.
And as I'm putting this on YouTube, the hate can come directly to me, barbalet@gmail.com. But yeah, I think it's very funny. In particular, Sam Altman has featured in previous recordings, or in a previous recording at least. And I think what's fascinating is the impact that DeepSeek has had on the US economy in particular, because the speculation associated with AI in general has, been a source of great income and great, I see this on my LinkedIn frequently, that, you can see people quickly moving to their particular spheres with regards to this political thing that's come out, even to the point of banning it potentially. So I think it's a fascinating time for this. My hope is that my stuff can be orthogonal to this discussion and just say, this is a tool, let's use it to its best. But then let's use it against let's claim there are 4 million open source. Please, again, leave in the comments how many actual open source projects there are. Could be closer to 500,000. But the ability for these things to then come to what is an extremely rich and extremely well human created, again, copyright and other things might be a secondary element to this, is incredibly powerful. And I think it will impact humanity very much for the better. And rather than being just a means of kind of personally noble goals, I love it for moral philosophy as well. I like having discussions associated with the Second World War and what came out of the Second World War in terms of moral philosophy. But, there are other ways of using these things. But I think practically, in the realm of programming relating to the vast quantity of open source that already exists out there, I think it could be incredibly powerful. Now, GitHub has already come to some of this. Some of these large open source repositories have already come to some of this, but I don't think they're looking at it with the same kind of community pluralistic methods that I'm trying to instill in this. Now, I know there's generative writing papers currently about generative AI, and I know all these things. So I don't know what will happen to this paper. I always find my Origin of Mind paper is very rarely referenced and very rarely remembered, but I think of it actually relating to a lot of interesting stuff that comes out of this still. So putting my life in another academic paper, let's see what happens to that. But I would thoroughly recommend to Matt to actually get into the process of writing these things, because once you've done one, you lose all that sense of I'm a hobbyist, I'm not worthy, I'm not clean enough for academia. It becomes very much like, okay, I just have to do this process now in order to produce this thing. Whether or not it's read, whether or not it's taken away, that's secondary. But I think that just the personal endeavor of writing an academic paper about something that you've worked on that you clearly love in some fundamental sense is very important. And my first example of this was I was one of 100 submissions where the remaining 99 were all academics. And I thought, oh no, there's no way I can get into this. Then 50, me and 49 academics. Then 25, me and 24 academics. And I realized very quickly that hobbyists actually have a really kind of novel and interesting way of looking at things, which isn't it can be drawn out of academia in some regard, but I would thoroughly recommend you publish your stuff and just get into the process of doing it. Because once you've done one, it's considerably less scary the second time you do it. And after you've done a few, then it's just like, okay, I know what I have to do. Yeah.
Right. And I intend on it. My struggle is that I have ADHD and I bounce around a lot. And so I find myself testing out new fitness functions, working on developing the core of Mega, which I'm getting surprisingly close to being satisfied to where I can go ahead and get my 1.0 release out, where I feel like I have everything where I want it to be. But I think my goal right now is going to be to get the real core features, the ideas that I have burning in my head out, and then to kind of present it as a whole instead of going and writing a paper about this part of it and then that part of it and then introducing things as I go. I would like to have the core components all the way developed and then be able to just say, hey, this is the algorithm, this is how it works, this is what I'm seeing coming out of it, without having to say, but I wish I could also do this. Because one thing that I'm looking at implementing next is breeding between metagenomes. So we can have like, say we're working on different related problems with the same set of base genes. So we have the same material we're working with, but we're applying, let's say we're working with chemistry and we have something applied to drug discovery, and then you have another one discovered to or applied to material sciences. Being able to take the metagenomes that have developed out of those and breed those together to come up with something in between the spaces, and trying to see how that relates to basically selectively breeding instances of the algorithm and seeing if we can come up with a way of being able to I guess share knowledge between and be able to direct it towards like selective breeding to make it more efficient at a given task. And those are things that I want to have built in so that, once I do write a paper about this, that it's easily extensible where other people are interested. They can just hop in and read the documentation and start building their own things. Because right now I can drop the code into, say, GPT and say, follow this template, write me a fitness function that does X, Y, and Z. And I can go from idea to a working fitness function for this in, an hour or 2 hours. And then I can spend the rest of my time tweaking it, playing with it, and seeing what comes out. And I want to be able to be at a point where other people can do that too. And so that when I do talk about this, then somebody says, that's great, I think I know an application for this. They can just go sit down and, go from start to finish relatively quickly and get to work on actually building the thing they're trying to build.
What's fascinating, I mean, having done the Biota podcast, was there was a period of time in Biota Live where we had biochemists, I think, connected with Lilly. I was contacted by a Pfizer chemist following as well, indicating that they were doing exactly what you're saying. They used, very basic genetic algorithms to look at splicing drugs together and this kind of stuff. And it's fascinating because this whole field has gone on. I don't know how much they academically publish around this, but just to have an insight probably 15 years ago now into the fact that the drug companies were actually taking this stuff very seriously and utilizing it because it gives them an edge nominally. The commercial edge that they get out of this kind of stuff is really fascinating. So yeah, I think what you're saying is exactly true, that out of these things come, a wealth of possibilities, basically.
One of the other things that I applied this to is automatic programming. I've played around with evolving a multiplexer where you have the mapping of the outputs, and you're trying to evolve the program that represents how you get to those outputs. And I'm looking forward to exploring that further, and I think that that'd be particularly interesting working with the metagenome breeding, because you can start with the same, programming tools and apply it to different problems. And I'm hoping to be able to see more of an impact towards being able to, I guess, have a pre-constructed like programming language encoded inside of the metagenome, so that we can apply it to, you know, rapidly test new ideas and new solutions. And the whole point of the metagenome, or one of the points of the metagenome, is to, I guess, distribute effort, so that, you know, the effort you make to solve one problem can be also used to apply to a different problem, because you already have the hierarchy embedded into the encodings, and so the work's already preserved there, and we can pass it on to other instances and apply it without having to start from zero. And so I think that that is a way of offloading, and eventually I would like to try and explore genetic programming further to see just what's possible with this, because it's an entirely different way of going about doing genetic algorithms, and I really want to see how far it can go.
We can't wait to see as well.
Sorry, Tom Ray's Tierra, bytecode, all this kind of stuff is worth studying in this light, because I think it'll show exactly what you're saying, that you can take almost a meta program and then see how the meta program evolves, and then reference down. So I think you know, these are strong. Immediately, I think of Tierra from that. It's not that everything's been done before; it's that things have been done in various areas in various different ways that are similar. But no, it's been a pleasure having the chance to chat with both of you. Thank you very, very much. I understand it's late where you both are, so I want to be respectful for your time in the evenings. But we need to do this again sometime. I'm looking forward to my conversation with Olaf. So if you see Olaf before I do, Dr. Adams, please let him know that I'm looking forward to having the chance to chat with him. And yeah, just expanding. You know Charles Offrey, right? He's not only a name, but a person to you. So
of course, he's great.
He's absolutely fascinating. The idea that he started off a seed here that is then going to replicate into this video is something that excites me. Matt, always a pleasure having you on. Discord is the way to get in contact with all of us currently, but in particular with regards to your work. I no longer feel as what, I'm not sure what the terminology is. I can't even remember the acronym of the board that got us all together. What is emergent artificial life? What's the name of the book? It was the first conference before the main A-Life conference. It's late night where I am too.
ERA?
ERA.
ERA, yes, that's right.
ERA. So the ERA Discord channel is a good place to kind of get in contact with all of us. And certainly, Dr. Khan, I'm looking forward to hearing from you. I'd love for you to TikTokize all these videos, and please get in contact. Pleasure chatting with you both. Thank you very much for your evenings.
Yeah, awesome. Thank you.
Thank you so much. Love the conversation.
Okay.